I'm Mary Kay Parker, and this Tech Talk will review the role and importance of knowledge management in medical modeling and simulation. For this presentation, state-of-the-art, relationship to modeling and simulation, why this technology is used and its importance, and where the technology is headed will be discussed for knowledge management in medical modeling and simulation. Knowledge management is the process of creating, sharing, using, and managing the knowledge and information of an organization using a multidisciplinary approach to organizational objectives. KM is a formal scientific discipline with a body of knowledge and framework to support it. Within the Navy, KM has only been recognized as a discipline with explicit processes for about 20 years. The Department of the Navy published a policy on KM in 2005, and this was updated in March 2014. At the department level, KM is defined as the integration of people and processes enabled by technology to facilitate the exchange of operationally relevant information and expertise to increase organizational performance. The purpose of Navy KM ensures a common understanding that extends from headquarters to the furthest echelon or tactical edge that results in shared situational awareness and a process to provide the information to enable effective and agile decision-making, increase the efficiency of task accomplishment, and improve mission effectiveness. In the private sector, KM is critical for decision-making, efficiency, and profits, and businesses use KM processes to achieve other outcomes. These include increased collaboration and idea generation, optimization of knowledge sharing, protection of intellectual capital, as well as capture and storage of knowledge for the future workforce. The Department of the Navy has identified 4 goals for KM. Continue to expand departmental awareness that KM applied to operational and business processes will enable significant improvements in mission accomplishment. Instill KM principles and methodologies into the Department of Navy culture. This includes expanding and supporting the KM community of practice, as well as sharing experiences, lessons learned, and results to foster collaboration, enable shortened learning cycles, and assist other efforts. Maximize the utility of existing Department of Navy KM experiences and resources, which include assisting commands in building on the KM experiences and resources of others, collecting, cataloging, and advertising existing plans, documents, topical guides, and other resources to assist command KM programs and projects, and fully utilize existing technology resources. Finally, a drive towards a more centrally supported, universally available, and executed Department of the Navy KM program. KM is more art than science because it must be tailored to the organization's missions, functions, and culture. You may not be aware of this, but you use KM systems every day. KM systems include such things as dashboards housed on DHA websites, your own command SharePoint, or communities of practice that you access through professional associations or memberships. You may be unfamiliar with knowledge cafes, but they serve as a means for putting people together to share knowledge and learn, connect people, gain better understanding of complex issues, and uncover risks and opportunities. Knowledge is generated from an organization's experiences or innovations that can be turned into actual physical assets, like reconfiguration of a hospital ward or development of a training curriculum. Knowledge may be organized and accessed electronically in a SharePoint site, shared drives, an external website such as max.gov or MillSuite, accessed through listservs or forums, or found in physical repositories such as books, libraries, manuals, files, and documents. Having a means of organizing, accessing, classifying, and retrieving this information requires governance, oversight, and training. Common repositories you may have access to include the Navy Lessons Learned Information System, NLLIS, housed under Joint Lessons Learned Information System, and the Center for Army Lessons Learned, CALL. Lean Six Sigma projects are searchable in Spider, a knowledge management tool designed to support performance improvement. Joint Medical Asset Repository, or JMAR, is an information technology system within the Defense Medical Logistics Enterprise Solution that provides 24/7 access to medical asset information for users on any computer. In this system, users can review such data as contingency and disaster response dashboards and metrics. DHA's CarePoint information portal is another example of a collection of dashboards that enable decision-making and performance benchmarking, which contribute to the development of a learning organization. The Joint Commission provides tools such as the AMP Tracer tool that allow organizations to efficiently manage patient safety risks and stay survey ready, using data input by users to build automated reports that can be reviewed by leadership and staff. KM facilitates organizational learning by adopting and implementing processes that manage knowledge, connecting knowledge holders with knowledge seekers, and achieving better operational efficiency and decision-making. Basically, KM links people to who they need to know and what they need to know to do their jobs better. These processes confirm the value of knowledge as an organizational asset. If we increase an organization's rate of learning, we increase its rate of innovation. NASA is a great example of a learning organization that employs effective knowledge management. Knowledge has become more complex and technical. The impetus for NASA to become a learning organization came after the Challenger and Columbia accidents. NASA realized they needed to communicate and share knowledge, capture and disseminate knowledge and lessons learned, and professionally develop their people so the right people were assigned to the right projects and programs. The Army also uses KM. They host a 3-week course that teaches both soldiers and civilians how to use KM processes to assess, design, develop, pilot, and implement solutions to fix knowledge and performance gaps within their unit. The Army Training Pub, titled Techniques for Effective Knowledge Management, provides guidance on KM processes to ensure mission accomplishment. The glossary in DoD Instruction 6000.18 defines medical modeling and simulation as the medical discipline that comprises the development or use of medical modeling and simulations. It involves the equipment, including hardware, and the software that implements a model or simulation or an adjunct tool. The hardware is software that is either used to provide part of a simulation environment, for example, to manage the execution of the environment, or to transform and manage data used by or produced by a model or simulation. Adjunct tools are differentiated from simulation software. They do not provide a virtual or constructive representation as part of a simulation environment. Simulation is a method for implementing a model over time. Modeling and simulation is a discipline for developing a level of understanding of the interaction of the parts of a system and of the system as a whole. The level of understanding which may be developed by this discipline is seldom achievable by any other discipline. Medical modeling and simulation may be used in pharmacy formulary management to estimate cost-benefit or return on investment through Monte Carlo simulations. Medical operational planners employ modeling of anticipated future battle scenarios based on a myriad of medical and non-medical intelligence sources. Anatomic modeling is used in surgical preparation for medical and dental procedures. Barriers to medical modeling and simulation include a disconnection between modeling professionals and healthcare professionals, a technology and sociological divide, fragmentation of healthcare, a lack of resources, and availability of key data elements. Healthcare lags other industries in the adoption and deployment of modeling and simulation. As an aside, much of the modeling and simulation research is not available in journals where healthcare readers might casually encounter or even actively seek out information on medical modeling and simulation. Young et al. State that another barrier to widespread adoption of medical modeling and simulation is the lack of cultural hooks that can make medical modeling and simulation attractive. The authors explain that, in contrast to healthcare, the military is highly vested in modeling and simulation and has the time and need to game out scenarios due to the high cost of resources and equipment or platform failure. However, the response to the COVID-19 pandemic may provide more impetus to increase medical modeling and simulation efforts. In examining KM in medical modeling and simulation, at least within the Navy, Dr. Don Sylvester, Director of Navy Medical Modeling and Simulation Training at Naval Medical Forces Support Command in San Antonio, Texas, states that these knowledge management processes have been in place but are not current. In the past, simulation scenarios were electronically stored, but access was CAC-enabled and invitation only. This limited visibility and knowledge sharing, and the Air Force had a similar arrangement. DoD Instruction 6000.18, signed in August 2018, established policy for medical modeling and simulation requirements management, and established the Defense Modeling and Medical Simulation Office, or DMSO. DMSO will centralize, coordinate, and consolidate medical modeling and simulation equities, requirements, and shepherding requests through the JSIDS process. The policy also seeks to improve the analytic efforts of the military departments, combatant commands, and USIS for planning, decision-making, and education and training requirements. Over the past 3 years, subject matter experts have been working on improved access and a better interface called Joint Medical Simulation Instruction Modules, or JMED-SIM, with the goal of standardized curricula to the fullest extent possible. Under DMSO, curricular requests will come through the DHA portal, while NMMAST collects readiness-focused curricula to advocate for standardization. The data within the JMAR is unusable due to non-standard nomenclature used in DMLS, the Defense Medical Logistics Standards Support System. A tasker was sent that enabled development of a baseline inventory of simulation equipment used throughout Navy medicine. Standardization will be a slow process, as equipment will only be replaced at the end of its life cycle, when it is hopelessly broken or as part of enterprise growth. The standardization is expected to take as long as 10 years. One of the barriers to standardized simulation, including how the simulation center is staffed and how much it is utilized, is dependent upon the command's priorities and the background and experience of the staff assigned to the simulation center. As a result, training outcomes can vary widely amongst the various military simulation centers. So the goal of the Joint Medical Modeling Simulation Department is to remove these variabilities. As we discussed at the beginning of the presentation, KM is a process of creating, sharing, using, and managing the knowledge of an organization to achieve organizational objectives. So where does information management fit? Information management is typically considered the technology or tools used to manage the knowledge generated by people. This might be the organization's SharePoint site, the internal and external websites, and how document libraries or repositories are set up. While we have knowledge that can be captured electronically and stored in systems, which is explicit data, we also have data that is tacit. Tacit data is unarticulated, hard to identify, and difficult to share. This data resides in people's heads and is usually what we call corporate knowledge. Knowledge management is a process, then, of getting information from one person to another. So where does document management fit into this discussion? Well, elements of a knowledge management system could include a knowledge base, a wiki, and a document library, as well as search tools that help users find expertise and capabilities within the organization. So all three of these terms work together to create, use, and share information. One of the best things simulation center staff can do is establish governance or rules for knowledge management. It is critical that staff do not spend their valuable time hunting for documents or data. Agreement on an electronic folder structure can help staff coming after you find the files they need to build on your work and sustain the corporate knowledge. The benefit for establishing folder structures and management rules is to eliminate duplicate files and maintain version control. Using standard document naming practices will help you and your successor find files easily and faster. The Smithsonian and NIST both provide excellent examples of file naming conventions. There is no right or wrong way. The recommendation is simply to pick one and stick with it. When naming PDF files, it is recommended that you use underscores between words and a title because systems will see this and convert it to a percentage to 0. In some systems, a space might signal a new line. For documents that have the same title but different months and years, like committee meeting agendas and minutes, begin your file name with the format year, month, day using numbers, then your committee name, and any other information that is important in the title. This will have the benefit of organizing all your committee documents in chronological order. If you commit to document tagging, then you can even use tags to use search tools to find the meeting minutes where you discussed a specific topic. There are a number of YouTube videos and tutorials on how to tag documents and files using the document software installed on your computer. It is well worth the time to review this in a staff meeting or with your training department if they offer computer learning. Within the federal government, there are rules for how long documents must be retained. You can work with your human resources and administrative experts to determine how long you should hold on to electronic files. A best practice is to set up folders labeled Archive, Old, or To Be Deleted, and to drop outdated or no longer needed documents into these folders. While you may not be able to permanently delete these files, at least they will not be cluttering the rest of your work. Most organizations do not have management practices for unstructured data. But there's value to the organization in some of the documents you maintain in your personal files. Because it is not accessible or searchable, that information remains locked away. Advances in technology may be valuable here. Natural language processing, cognitive computing, and artificial intelligence have the potential to make it easier for people to find the information they need. As discussed in the VV&A section, using templates can ensure that all data is captured at the beginning in a standard format for a project. Some of the scenario examples used in earlier modules of this course could serve as organizational templates to ensure ease in updating and performing regular reviews for clinical accuracy and relevance. For medical modeling and simulation in military medicine, standardization of modeling and simulation assets has the potential to improve clinical performance, reduce variability in practice, and provide metrics for return on investment and cost-benefit analyses. Data generated by simulation assets could be aggregated to create large data sets for analysis and benchmarking across the enterprise. These data sets could identify positive deviance to capitalize on exceptional learning practices at a specific simulation center that could be disseminated to all simulation centers, or identifying practices that require remediation at another location, thus ensuring standard performance practices for a specific skill set or procedure. From an acquisitions perspective, purchases of standardized simulation equipment could reduce costs through volume pricing negotiations, and staff training could be enhanced through the same process for acquiring vendor training packages. Data could be pulled from these actions to drive future purchases or consider different options for training. Educators may be interested in the reusability of clinical and simulation scenarios with data that can be evaluated over time for effectiveness. Additionally, scenarios that are standardized can be mass updated when clinical guidelines or practices change, reducing the amount of time required to perform administrative corrections and ensuring these updates are performed at all simulation center locations or online repositories. Finally, educators may be interested in benchmarking the outcomes of student learning, and this can be done through checklists and tests, as well as with simulation equipment-generated data, which might be helpful for evaluating the impact of curriculum changes. Educators might also welcome the ability to rapidly generate just-in-time training scenarios that can be collaboratively shared for crowdsourcing and review, as well as developing techniques for temporary upskilling or retraining in emergency situations. Knowledge management in the form of big data may be able to identify trends, patterns, and associations that can improve the overall delivery of medical modeling and simulation in the military and demonstrate positive influence for warfighter survivability. APQC, or American Productivity and Quality Center, provides a number of resources devoted to innovation and knowledge management. Their white papers and presentations provide cross-pollination for sharing knowledge and best practices in modeling and simulation. In conclusion, effective knowledge management can foster organizational learning that transforms organizational culture. At the very least, it can improve the transfer of corporate knowledge throughout an organization and eliminate reinvention of the wheel. References are provided for additional review.